Okay, so I'm here with Eugene. We are in Singapore. This is the first time I'm podcasting in Singapore. It's the first time I'm podcasting with my Singaporean accent. Eugene has been a very valued part of our latent space Discord for a while, and also diving deep into RWKV. I think you're actually the first person that brought it to my attention as like a potential Transformers alternative. You're also CTO of UILicious, which is a UI testing company that's in Singapore here.
Yep.
Anything else that you would flag out as like your high-level intro?
Like what brought me into AI and machine learning is actually I originally wrote GPU.js, so that allows you to run JavaScript code on the GPU. This was pre-neural network boom, and my project got picked up by Brain.js and merged in, and that's how I actually went to the mad rush. There's neural networks, and then now subsequently large language models.
So, okay, let's talk about that a little bit. What was the origin story for GPU.js?
So the origin story for GPU.js is that me and my friends at NUS, the local university here, we just wanted to run JavaScript. I think it was like the era where everyone's just trying to do everything on Node.js and npm packages, and we were just like,
Was this like 2016, 17?
Yeah, it's quite far back. And then we were like, let's just do this for fun. Let's just prove that you can run JavaScript on a GPU, just because it should be faster, theoretically, for matrix multiplications. This is like foreshadowing. And it was meant to be a joke that, yes, you can run JavaScript on anything. And we managed to get it to run it for that very narrow case of matrix multiplication. It outperformed the base V8 engine by running it on the WebGL.
By a lot?
Yeah, but especially when you scale past 2,000 dimensions. There is a gotcha because you have to transfer your variables from the JavaScript space to the GPU space. So anything less than 1,000 by 1,000, it tends to be not worth it. And then we just let the project just sit there on the internet, and it just sat there for one whole year until neural networks came in full steam, and someone picked it up and plugged it together, and it's like, hey, we can train neural networks in the browser in JavaScript, and that's how Brain.js grew on top of GPU.js.
Right, and just because I have a little bit of background to this, I actually still don't know what specific APIs. Are you using WebGL to are you basically abusing WebGL to get access to the GPU? Like, how do you get access to the GPU, basically?
It's not really so much of an abuse. So the crazier abuse part is actually upfront. So what we actually do is that when you submit a JavaScript code to GPU.js to execute in parallel, so I think you can just view it as a very common reduce function. So you got your function and then your data. So you got your large data arrays, you put it in there. What happens is we serialize your function into code, and then we do an analysis on it, and then we translate that into WebGL code. So we had to implement a lot of things that were in JavaScript that were like shader codes. At that point, it's still considered shader code that did not have support for. So, for example, if you want to do large number manipulation, and we only had small floats in the system, what we just had 2 floats, and then we just abused the heck out of it.
To simulate a big int or
things like that.
Okay.
So that's in essence what the GPU.js library did, is that we took your code, abstract syntax tree, analyzed it, we figured out what it does, then we rebuilt the code in WebGL.
Okay, why not why this? So this is a compiler.
Yeah,
why the compilation approach instead of like a library approach where people can just kind of use functions that you've made?
I think it's back to the original goal of making it a joke more.
Right, so like, run JavaScript on the
literally run JavaScript.
Okay.
So we didn't want you to need to learn new commands and things like that.
Yeah, that's pretty crazy. Yeah. Okay, so and because I had this initial confusion, Brain.js has nothing to do with TensorFlow, even though I think both were run by Google.
Brain.js is not run by Google. It's more of a community-driven project.
Okay.
So, and I think it's commonly confused with TensorFlow because, let's be realistic. If you want to train real models, you're not going to train it on JS. you're going to train it directly with QDAM and so on because it just performs much better. But there is a benefit of running it purely in a browser because you make it completely possible for like teachers. And yeah, in fact, one of our most popular users were teachers teaching students on how to make neural networks. And the barrier of entry is it's not you need a CUDA, you need a setup. No, you just need your browser, which makes it significantly easier, even though it's all toy models. And in that use case, TensorFlow.js and Brain.js is functionally the same with just different APIs, at least for serving this target market.
Yeah. I mean, it's the best user experience for sandboxing. You're just spinning something up without dependencies. Okay, and then so fast forward after GPU.js, what else did you get up to?
So after GPU.js, that's where I move on to running my own startup, so UILicious. And I guess that was because I was at the time professionally working for banks and private institutes. And I'm surprisingly like for me, it's like why we have so much high-tech applications, but at the end of the day, we are just testing a lot of things manually. And I just wanted to automate that. And that is why I started effectively a test automation company. And even then, early on, we actually tried to automate things more with AI even, but we found that at least at that time, it was not ready. And fast forward, so we built a product around it where you can automate your browser using low code. Just go there, type simple commands, go to Google, click on this text, run.
Which is another compiled language, right? You had your own.
That's actually in JavaScript.
Testing language.
There's a JavaScript library, but we focus on making it easy for manual testers.
Right.
So like if you see all the existing, let's say, browser automation libraries, they are all heavily async based.
Yeah.
Teaching someone with zero programming skill how to deal with asyncs is a complete nightmare.
Yeah.
So we make steps that, for example, we make it synchronous. We don't expect you to know CSS selector. We just ask you for your text on screen.
Yeah. But it's still JavaScript.
Yeah. Then that runs on Selenium, and then it does all that. So it's not AI, but the big jump for us was that subsequently, more recently, because we've been building our data set, we started having our own self AI on our platform where you can just describe your test and it will generate for you.
Right.
Including hallucinations.
So lots of fun. And so how did you were running UILicious, which is a low-code platform. I got the first demo maybe 4 years ago.
Yes.
And I was like, okay, fine, you're doing testing. There wasn't an obvious AI angle. I mean, now that you explained it, it was great. But like, what was your personal, like, okay, I'm going to be the dedicated AI guy for UILicious?
I think because for the most part, we knew that. Okay, so one things that I found very interesting with the huge transformer boom right now, right, is that traditionally, and I think I have an article on this also, is that like when you tell companies that when you want to build your own AI, you need a really large data set. And over time, actually, the amount of data sets that you need is actually scaled down because you can just now fine-tune
foundation models.
Yeah, fine-tune foundation models. And when we started UILicious, we always knew at that time, because a lot of our other companies that were launched at the same time were dealing with neural networks, that at some point, the data that we've been collecting data on, let's say, how to do testing website, it's just a very specific focus. Basically, every single test that has run on our platform, unless our customer has opted out or delete their account, basically privacy-related stuff, we actually still retain the test data. And that's something that we always felt that was useful in the long run to be able to actually build a huge training model. The irony of that was that even though we were building all those data sets, as the threshold came in and the transformer boom happened, we realized we don't actually need that big of a data set anymore to actually get a functional AI to.
Can you give order of magnitude? What were you expecting, and then what did you find? Like, how off are we? Like, do you need like millions of, I don't know, of test data, and then you found that it was just thousands, or like, just quantify something like that.
So, and I think this is actually one of the key insights for especially for people who is like trying to build on top of transformer models for their commercial. Pre-transformer large language models is we will always be thinking of like in terms of like 100 gigabytes of data, 1 terabyte of data, like millions and millions of record for all the different examples. Post-transformer, it's literally, you probably need only like 1,000 or 10,000, enough like data that you can literally get an intern a few weeks to just get it done. And you have a working model. It may not be that great, but frankly, every piece of data you add after that is a diminishing returns.
And it's specifically structured as, I mean, because it's a language model, it doesn't actually have any inherent understanding that it is automating the browser.
Yeah.
So it's presented as like a prompt answer pair, like question answer pair.
Yeah. So typically, for at least for our internal model that our users are using, it's presented as, here's the prompt, describe your test or what you want to modify the code, and then subsequently it generates the code for you.
Right.
So it's and now in hindsight, it's now basically Copilot. Yeah. I think now Copilot is adding that chat widget. Are they fully launched yet?
Yes. I actually downloaded it yesterday. I haven't actually used it yet, but it is a separate VS Code extension. So there are now 3 Copilot extensions shipped at GitHub because they have shipped their org chart. I'm friendly. I'm quite friendly with that team, but it's very funny. But just to come back to you, so did you implement this with GPT-3? Is that where it was?
So what we implemented, what we trained for, at least our code model, we based it off the Salesforce CodeGen model.
Okay, right.
So that was the foundation model that we built on top. We are looking into replacing it in parts, but that becomes a longer conversation.
CodeGen being the first really credible open source code specific language model that was released by literally anyone. I think about 3 years ago. And then they recently released CodeGen 2.
Correct.
Any opinions on CodeGen 2, just while we're on this topic?
I actually think, no, so in terms of like CodeGen, one big appeal for the CodeGen and even CodeGen 2 model is that Salesforce took a very clear and clean approach to the licensing. Meaning
they were very, very clear that everything that they trained on was open source.
Yeah. MIT, they didn't touch the problematic licenses.
Yeah.
So, and you can imagine.
And you think that Copilot did?
Knowing Microsoft's statement on how liberal they were about GitHub data, and they were saying, they used the term that it's under fair use.
I see.
Yeah.
I see. Okay.
I have no reason to believe that they didn't. Right. But this same problem happens to actually a lot of existing CodeGen models, and that was actually the main appeal for me for actually building on top of the Salesforce CodeGen model. Mostly also because like for us, we deploy on-premise into enterprises in Europe, and they ask questions.
Right. So what does this deploy on-premise mean? Like you pack UILicious into a container and you give it to them?
Yeah.
And then there's like a license fee or something?
Correct.
Okay, cool. That's very interesting. Yeah, okay. I don't know if I have any other questions based on that. Anything else before we go into the reasons for alternative models?
Okay, so anything else do I have there? No, I don't really have much. For alternative models, so yeah.
So let's set the premise, right? Like transformers have won for now.
They have slayed the neural networks.
Yes, and it seems like you have had a history with machine learning since before transformers, and now they're at kind of like the peak of their power. And I see that there's a desire for alternative models for a number of reasons, but I'm very curious as to what drives your personal interest in alternative models.
So first things first, to be clear, majority of our AI is still based on transformer, at least within my company.
Yes.
But what drove me into alternatives beyond transformer, in essence, once we actually managed to get our bot to generate UI testing code, the most obvious next thing that our customers started asking, hey, let's say the test failed. Can your AI now analyze my website and then tell me what's wrong and tell me what to change? Okay. Basically, they're getting lazier and lazier. And that's to be
humans are very good at moving goalposts.
Yeah, and I was like, okay, that's something I was working on, and we had something working for toy websites. But the first thing that we hit was that we started one thing that we do and internally is that we look at the, I think what was the list? Top 100, top 1,000 websites.
Okay.
And we basically just run, or we actually do run our test platform against that to make sure that our code works against like any front-end platform.
Well, what do you mean run your test platform, right? Because you don't have tests for them.
Yeah, we have some very rudimentary basic tests, like go to website, see something, click something, add to cart. Okay. Yeah, that's it.
I see.
The idea is more of like, because there's so many frameworks out there, and
you just want to make sure you cover all of them.
Yeah, and so we did the same thing for our AI. And the first thing that it died on was literally Amazon.
Why? Oh, 5 megabytes.
Yeah, I think you heard me mention it. So it when you are trying to analyze a website, it's like even like we've been talking about increasing token count size, right? But for e-commerce websites in particular, even if you strip off the CSS, even if you strip off the JavaScript, having the entire HTML in megabyte size is not unheard of.
Yep.
And that's where it's like, how am I supposed to solve this in terms from an AI point of view?
How many tokens would that be? Like,
oh my gosh, easily.
I mean, today it's nothing, right? Like 10,000 tokens, no, it's not that much, right?
No, because the tokenizer doesn't do very well with HTML content.
Oh right, okay.
So you could easily be looking at over 1 million tokens.
I see, which is still too much even for today.
Yeah.
Did you look into making your own tokenizer?
That's something that we explored. I think what we found more realistic was to actually pass the HTML into a more token-friendly format.
Yeah, right.
So this way we can still build on top of the existing models. But yeah, we are exploring that as well. Okay. But back to the alternative. So like the key things for me and was at that point, and subsequently I think I showed you like the experiments with like English compiler and things like that, right? AI agents generating code. You also have your own small there. Was that the context size is a real problem, and transformer inherently by its nature, at least vanilla transformer, I know there's transformer XL and some other attempts, is that it quadratically scales with the context size. Mm-hmm. So if we scale to like, let's say 100,000, that's already requiring a shit ton of compute and VRAM, and I don't even want to imagine what happens to 1 million or 10 million. And that's where I was like, okay, this is a fundamental problem that needs to be changed. If not, we will not go past this. And I think there's also now like a lot of people who are very interested in like models that can handle large context size, because they also want it to be able to use in use cases where they never need to fine-tune, because fine-tuning is a pain, apparently.
Yes. That said, okay, well, there's issues with just throwing everything in context, right? Like yeah. It's shown that retrieval is only best when the item that's relevant is in front or at the back of the context window. So it's basically, I'm just like, maybe we've just tapped out. Context is working memory, and maybe it's like, maybe transformers are very similar to humans in that our working memory is only of a given size. If you try to artificially extend it, you just make it very lossy. Yeah.
So that's where I ended up landing on the RWKV model, because in that sense, right? So one thing that I always found very weird for transformers, but I mean it's by design, is as you infer each token, you will recomputing everything up front. Mm-hmm. That's the quadratic part, and while you're mentioning about the working memory problem, in theory, with enough attention heads on it, mm-hmm. and people seems to be trying to cram more and more attention heads into the process, it could scale that way, ignoring compute costs.
Okay.
And yeah, ignoring compute costs is like just like a very liberal, let's just throw as much H100, it doesn't make sense. But RWKV was fundamentally a neural network at its core. It ends up scaling linearly as it goes through the tokens. It will still suffer from the memory issue. Within the RWKV, we do like measure two separate things. So like one, we call it the perfect memory. So the model will have only a certain amount of capacity where it can remember things perfectly, just like humans. And then beyond that is where it will start to discard things from its perfect memory.
Right.
And I felt that this was actually a lot more in line with our goals and commercially, and also what I felt was that was more useful in the long run because it's cheaper compute and it could be potentially parallelizable for a very long run.
Right. So we're going to go into our RWKV paper in a bit, but one thing I wanted to ask, you kind of glossed over how you found it in the first place.
How did
Because you're not a researcher. You're not like, I don't imagine you're like reading papers every day or something.
Until recently.
Until recently. How do you find it?
How do I find it?
And how do you know like this is the one to bet on versus there's a bunch of other alternatives, right?
I think what was quick, I think it was rather quick after I concluded that Transformer as it is will not scale to 10 million tokens.
Okay.
And
so by the way, you mentioned Transformers XL.
Yeah.
We also did an episode on flash attention, which helps to make part of it sublinear at least.
Yeah, but that is like way after I already dived into RWKV. So history-wise, at that point in time, Transformer X, we are talking about like the when 4K was the limit that everyone knew.
Right. And this was last year. I mean,
yeah.
Just to set context. Okay.
Yeah.
Okay. And then yeah. So and you just kind of were searching around. You found our RWKV. Presumably, like, do you go straight into the Discord? Was it like primarily a GitHub repo? Like, what was it? Because as far as I can tell, there was no paper until maybe about 2 months ago.
Oh, and I talked about it before the paper, right?
Yes. So you found it before they did any publicity, which is weird. It's not normal.
Fair enough.
So what happened? What did you do?
So what I did? Okay, so it was basically I believe. Okay, so it's a mixture of things because it's like I was searching GitHub, I was searching like forums, other Discords, and also like blogs actually.
Can you shout out which Discords and which forums were super helpful to you?
Super helpful will be mostly UILicious forum, Discord itself. Blogs, it's very hard to pinpoint to it because at that point in time it was just like
random people's blogs.
Yeah, I was just like getting all because everyone was just creating lists of lists, right?
Yeah.
And I believe you also have a list of lists somewhere.
Yeah, but mine is so I would consider myself very trad in the sense that I would just follow the large model labs. Whereas the kind of list that you have to follow in order to get to something like RWKV before they've done any publicity is the non-trad, like, the kind of people that is now working on Luz Hermes, Wizard, that like no credentials. I don't even know who the hell they are, but they're just working on it.
So this the list. What? Okay, this is all foggy memory, and I might be hallucinating this because there was too many lists. But I believe the list that actually what brought me to RWKV was that beyond. So this is something. This is a topic that we can actually touch upon later, right? Beyond OpenAI's model and beyond ChatGPT and Claudia, the two big models, right? Outside of the English-speaking nations, right? A lot of the open source models really fall flat, and that is why like when you actually go through like lists for like doing things in other languages, RWKV actually stood out at that point, and just on the basic premise, and we're not even talking about architectural advantage. It's just the basic premise that they imported the data set in other languages in the training data.
Yeah.
And
was that because I mean I imagine 99% of your customers are English.
Yeah.
Was that really a driver for you?
It wasn't a driver,
you're just
but
trying to explain it.
Yeah, that's how I landed onto like all these blogs and articles.
And can you say when you say fall flat, the main one that I know about is there's a tokenizer penalty for non-English.
Yeah, that's that.
Right. So like Chinese is up to Chinese or Japanese or Thai or something it's like 16 times the number of tokens for a typical English sentence.
Yeah, but even before that, right? Because I mean, yeah, I think you understand. Like a lot of community users, they want to not use the commercial APIs.
Okay.
So they try to find open source models.
Yes, and we'll talk about the not safe for work people. I really want because you've actually talked to them. I have never talked to these people, but like when I discovered them, it's a huge community. They're extremely passionate and they're actually good.
Yeah, they're really good.
They're good at this. So let's talk about them, right?
Yeah.
But yeah, we can talk about it later.
Yeah. So, so they don't want to use the commercial models, and they want to use the open source model. And there is a tokenizer penalty, which is true. But I think on the more fundamental basis, right? If you look through the data sets, And this is also partially informed because the way we set up our evals, all our evals are written in English, and at least for the majority of them. And if we are racing towards building AI models, at least right now, as you see all the companies as they build their open source model, and they just want to narrowly focus on the evals, adding in a foreign data set is actually a loss because once you're below a certain param count, so we're talking about 7 and 14, right?
Yeah.
The more you add that's not in line with your evals, the more it will degrade. And and they just excluded it.
Yeah.
So the model
the priority is English. Yeah.
Yeah.
I get it.
The model just fundamentally didn't support.
Wait, so what's the trade-off? Like, I mean, okay, so English and Chinese, or there's all these other languages. What do you pick? Like,
so RWKV started with also in context, the main person leading the RWKV project, Bling, is from China. So he naturally has an interest to make sure it supports Chinese. Of course. Yeah. So English.
And there are a fair amount of bilingual models, essentially, that are English and Chinese from the major universities in China.
So we started from basically English, Chinese, Japanese, Korean. Frankly, this is large part mostly because there were fans in those communities that came on board, and then subsequently we try to onboard other languages as well.
Yeah. But these people are, like, again, they're not researchers.
Nope.
No money, like,
nope.
Training on their home GPU lab or whatever, right?
Partially true, but so how this works out, right? So for the RWKV model, at least how I see it works out for a lot of the other languages was that we have the foundation model, and this is the foundation model where we just kind of say evals be them. Let's just make sure to include all the other languages.
Okay.
And when we included the other languages, right, the model works for most parts for the other language. Subsequently, these individuals who wanted to use these models for their respective use cases will then fine-tune respectively. Because it's easier to fine-tune in another language for your use case than, this is just classic fine-tuning, than to train the language from scratch.
Okay.
And I think more recently, and this model is not 100% trained yet, more recently, RWKV has released what we call the world model, where we go the next step of even including all the translation data sets that we can find, even for minority languages that people and in our Discord. Because the goal for them, the long-term goal for us, at least internally, is that we wanted an AI model for everyone. And everyone does not mean USA, it means the world.
Well,
so there are a lot of languages in there.
Well, is it Asia biased, or, give me a sense of, like.
It's probably, no offense, it's probably still going to be US biased in terms of, like, knowledge, because what we are doing is still power red pajamas for the knowledge. Okay. But in terms of language, we add all the other languages, wiki and translation set. So it's hard. We haven't fully evaluated the bias yet, but I'm quite sure that when disproportionately knowledge is still within the English universe, there's the bias is there. But frankly, we are still at the stage where can support the other languages.
Yeah.
and I think I mentioned this is one of the interesting parallels that sometimes I have, right? Is that I can see in the Illustrator forums and all that, and then we're talking about alignments. And like we're talking about it in very
which is very keen on safety and all that, which is great, but like it's not your goal as the RWKV community.
And when you talk to like members of the community that came on board, it's like, I want to get this to work for Korean, Japanese, Thai, Arabic languages, and so on and so forth. They just want something that worked. Yes, they don't want it to be. They are not after the big model that does everything. They just want something that they can play with in their language, and that was very important to them.
Yeah, and these are literally just hackers doing it for personal enjoyment.
Correct.
Not yet for work.
Yeah.
Or maybe some of them for work. You don't know.
We don't know.
Yeah. Okay.
The whole character AI category, there's quite a number of them using it for that. So professionally.
Professionally, okay. As in they run character companies. Let's call it. Okay, cool. Yeah. I'll signal that I'm interested in doing like an AI waifu episode, and I need to find like the perfect, like someone doing that and to just explain everything that they found. Actually, I'm very interested in like basically pairing this with a psychology professor who can ask like psychological questions about like what have you found about human sexuality and human behavior when they're just talking to an AI bot. I think it's very, I don't know, I think no one's covering this. So I listened to, actually listened to a few psychology podcasts, and they're completely out of the loop. They're not even aware that this is going on. And it's so huge. It's like literally millions of people, right?
Yeah, so they're not aware about people using AI, I guess, in the form of therapy?
Yeah.
Or personal companionship?
Well, they're not talking about it.
Oh, okay.
It's maybe not polite conversation, especially because it's like not safe for work, but like I think it's just an emerging category that is interesting.
Yeah, especially, I mean, just going to be cut straight to the chase, especially Japan.
Yeah. Well, and then there's also like, we always say AI waifu, but actually, I always call this like AI husbando. It's actually
there's that too.
It's bigger.
Bigger?
Yeah.
I wasn't aware about market sizes.
Bigger. Yes, I've actually looked into this. And so I can resolve this with a very, very simple example that everybody will understand, right? Amazon Kindle Unlimited is the subscription service where you can just pay a monthly fee and get all the books you want. Mm-hmm. What sells the most?
Romance models? I mean romance novels?
For women.
Oh.
Because they like to read about romance.
Oh, that makes a lot of sense.
Men are visual, women are verbal.
And in this case, language models are text.
Yes, exactly.
I mean, we do try it. They do try to dress it up.
Yes. Okay, cool. So I think that's great. Should we pause here and then I'll switch to the screen?
Sure.
Okay. All right, so we have it pulled up. We are going to screen share for the bulk of this. So if you're listening on audio, it might be a good time to switch to the YouTube channel. So we're just going to start with an intro. What is RWKV?
So RWKV is a modern recursive neural network with transformer-like level of LLM performance, which can be trained in a transformer mode. And this part has already been benchmarked against GPT-NeoX in the paper, and it has similar training performance compared to transformer models of the same data set and parent count. So specifically the GPT-NeoX model. So the key thing is that even though it's matching in performance while trading blows with GPT-NeoX, it's doing all this without attention layers. And in the process, right, it's actually having a much substantially lower compute based on its design, and also because it's a neural network, which we'll dive into later why that's substantially lower in both training and inference. And this is back to, like I mentioned previously, transformer, at least traditionally transformer until we found out about transformer XL and things like that, tends to scale quadratically based on the context size. And this applies not just in inference, but in training. Mm-hmm. And due to how this is still a neural network in its heart, even though it can train like a transformer, it's able to do so much more efficiently and faster. Especially like when you hit context size of 8K, 16K and above. And once you do like quadratic and linear, the differences starts to like go, of course, crazy once you scale the numbers up. And that was the main benefits of the RWKV model per se. There were a few prominent researchers when they actually reviewed through the RWKV paper when it came out. They did highlight an important question of like, is this like evidence to literally, maybe all that really matters is that we need a large data set and a scalable model.
That makes sense, obviously, to some approximation. But you are still using attention?
No, we don't use attention inside.
Okay, yeah. Maybe let's rewind a little bit.
Specifically attention as you understood it. Yeah.
Okay, tell us more.
So we use weighted receptors and
if there's any diagrams I should pull up, let me know.
Oh, okay. So we are using AFT. So this attention-free transformer, and this paper was written by Apple.
What the hell is an attention-free transformer? Okay, this is unusual.
Yeah. So we basically we use the weighted retention weights, and we compute over it, and in essence, right, this is like the classic like stacking more layers. Once you do on top of it, like you don't really need attention. Once you have enough weights and layers stacked on it.
Okay.
I don't know whether we want to go into the deep dive of AFT.
Sure.
That's
interesting. I've never heard of this paper.
Yeah. So this was written by Apple, and subsequently we integrate at least Blink, the creator of RWKV, took this and applied it to a language model and scaled it up.
Right.
And that is how we landed on RWKV that doesn't use attention. So sometimes within the community we use the word light attention, because what happens is that these layers and these weights will still play the role of attention. They will.
I was going to say you end up approximating attention.
Exactly. So it ends up like looking at the tokens or parts of the memory and then applying it to the output. So and the key benefits is that, because remember the attention models, the multi-head part, it will need to scan all the tokens back and forth. Yeah. This removes that requirement, and hence it reduced the overall compute count. I might be jumping back and forth a bit, but that's the one of the key essence of the WKV segments, and we call it light attention. And this is the part where I will disagree with the RWKV community in some parts. I think that was a bad name.
Whatever.
because it's still.
Why is it a bad name?
This is the part where, because when the RWKV paper came out, right, and then we talk about like we use this, and we call it light attention, but by design it's really nothing like your existing attention head models, and it ended up like sidetracking the hacker noon debate on like one corner. It's like, no, this is technically attention, approximating attention. Then another group was like, no, this is not attention.
I see.
But I'm like, propose a better name, because I have no idea what to call it.
Okay. What else should people know? Maybe we can explain what RWKV stand for.
You have to open that in the paper. Recursive.
I think the paper is here.
Yeah, so Reinventing RWKV, receptive weighted key values.
Okay.
Yeah.
And each of these are like actual things that you model in the code, right?
Correct. So we can go into that.
Which attention historically is like query key value.
Correct.
Okay.
So do you want to jump straight into the layer architecture?
Should we cover something else first?
Anything?
I mean, we can anything like
high level, right?
High level. Okay, there's a 7B, there's a 14B, there's a
okay. So let's.
What are the assets or the artifacts?
Okay, so on before we go into the nitty-gritties of how the layering and everything works, right? On the high level, right? Currently, RWKV architecturally as a model, it can be. What we have already proven is that it can be scaled and trained like a transformer. How I do so, we'll cover later, and this can be scaled to as many parameters as we want. Currently, what we have is dominant. Our main models is the 7B model and the 14B model, which you can find on Hugging Face or respectively our demos. We also have that will be the RWKV Raven models. These are also instructionally tuned for.
It's not here. Okay.
I'm so sorry. And probably at the bottom, models. Down, miscellaneous models.
I see.
Yeah. Okay. It's on Hugging Face. These are the UX issues that I need to fix.
You only discover it when you talk it over.
Yeah,
with somebody.
I know.
Okay, so there's world, there's Raven, there's music. Oh my God, there's novel. What is all this?
Okay, so before the current main models is RWKV for the Power and Raven. So Power is basically just a Power Plus model.
What is Power Plus? I know about Power, but what is Power Plus?
Random data sets that the community threw the Power.
How many tokens worth?
I would just say slightly 1.1 or 1.2 times the power.
Okay.
Yeah. This is not instruction tuned.
Okay.
And stuff. Yeah, the plus one is typically all the other languages. Okay. Subsequently, Raven are the instruction tuned model. This is the current main complete models. We subsequently have.
And the instruction data sets are from?
Typically GPT-4, but then we
scrub it for every move or the
It's
as a large
language
language
model.
model.
So yeah, this would be the uncensored. There's some other project that's kind of doing something similar, and they call it uncensored, but really they just scrubbed it as a large language model stuff.
Yeah.
So that makes it technically breaking TOS of OpenAI, right?
Yeah.
Okay, but yeah,
But I mean,
that's a later problem.
frankly, let's be honest,
Yeah.
even if we don't remove it, someone is going to remove it.
I mean, so there's ways around this,
Yeah.
which is you get clean data sets that are not GPT-4. Like, so the one that I typically mention is Yannick Kilcher's Open Assistant.
I believe that was included subsequently as well.
Yeah. Yeah, obviously all these release orders are all over the place.
Yeah.
So okay, Raven World.
So Raven is the instruction tune model.
Yep.
And then subsequently, the world model is a new model that we are training. It's not 100% complete yet.
Okay.
With the focus on a new tokenizer and all the languages. So what
All the languages.
all the languages that we can grab from the internet. All the wikis in all the respective languages. Please don't use Waifu. Waifu is not yet ready.
Okay.
Yeah, forward.
No, I just want to see the description, right?
Yeah.
Like, what do you mean when you say all languages? 100 languages. Okay, fine.
So 100 languages. It wasn't really a very precise science. We just basically whatever the wiki tool that allows us to download the X wiki languages. If it works, it's in the set. If it doesn't work, skip.
Yeah.
And all the and major prominent Oscar translation sets. So as you can see, PAL, red pajamas.
All right. What is Oscar?
Oscar is just a common term that we use in. You can just search Oscar in Hugging Face dataset, and it just means translations.
Okay.
So you can find like English, XPair.
I see.
Yeah, all the respective pairs.
Okay.
Yeah. So and then all ChatGPT data I can find.
Okay. So 70% English, 15% multilang, 15% code. Is there a strong grounding for why 15% code?
No, it was already there.
Yeah.
The focus of the world model was not to improve everything else. Okay. It was literally that 15% multilang. We wanted to increase.
It was English and code, and then you just added multilang.
Yeah, we had a fair bit of multilang, but we wanted to bump it up.
Right. So this is primarily English. Whatever. Okay.
Yeah.
All right. What I would like is basically a visual of here's all the building blocks and here's how they combine to create all these things.
So we have the RWKV architecture code.
Yeah.
So that's the main model building block. Then basically we feed it the data. Power plus, red pajama. Then subsequently some of the code data. For the world model, we subsequently add on top of that all the translation Oscar sets and so on.
And so you're training these things. You've mentioned that you're intentionally taking a hit on evals, on traditional evals like MLU or whatever.
I wouldn't say intentionally. Also to clarify, I am not training it.
Yeah.
I'm just part of the community.
Of course.
The community and Blink is the one training it. But I would say it's more of the lack of care for the evals. So the reason why we add things to the dataset was never about improving evals. It's about directly in response to user feedback.
It's like, oh, not good enough at this, so okay, just throw shit
yes,
in.
literally along those lines. And so take for example, right? Like even for Raven and the world model, as we go through the training stages, right? We specifically ask people in other nationalities within our Discord community to test it for their language. And our rule that we set is that, informal rule is that the only person who can decide if whether this improved world model is better in Japanese or Thai or whatever it is a native speaker.
Yeah. Where does it take place?
So it's mostly within linguistics, but sometimes we do a shout out in general as well.
Okay, linguistics. Yep. So do you have a appointed ambassador? Like you have 100 languages.
Yeah.
You just have a czar of Japanese, a czar of Thai.
It's not so pointed. It's more of like, hey, this is the Japanese model. Please try. It's not.
But there's no the Japanese model. There's one model. There's the world model.
So if you go to world model, I don't know whether it's inside here. No, 4. Sorry. 5.
Sorry.
5 is. We should never put 5 on top because 5 is fully experimental.
Okay.
So under files and versions.
I see.
So
I see.
So there's a Japanese specific tune.
Yeah.
Chinese tune.
Arabic.
Then for all the other smaller languages, we actually ask them from the base world model.
Yeah.
Itself. So feedback on that.
Uh,
So we actually released previously like 10% train, 15%, 20%. Like as it goes through the stages, and then it's like, hey, is this working?
Yeah.
Is it regressing? So it's like evals, but real
done by real humans and
Yeah.
not systematically. Is there a reason that you release? You also so you mentioned 7B, 14B, but I see also 0.1B, 0.4B, 3B, 1.5B. Like, what is that useful for people, or
Yeah.
is it just for research? Or
0.1 and 0.4 is frankly more for research, but some people do try to make use of them. Nothing stopping them.
well, I mean, is extra, like, these are just different architectures, different dimensions.
Yeah.
So it's actually extra cost to you to provide these things.
Oh, but specifically for the world model, because we are trying a new tokenizer, we are, and the reason why we're trying a new tokenizer is that as I think is that one thing that we found, more like I found surprisingly frustrating in existing tokenizer was that it was very English centric.
And the existing tokenizer you took from GPT-Neo.
Yeah.
Okay. And just to, I need to backtrack a little bit, just for people who are not following along. GPT-J was the original Luther reproduction of GPT-3, and then GPT-Neo was the bigger GPT-J.
Yeah, you can pretty much
20B, something like that.
Yeah, I do believe they have a 20B model.
Okay.
And
And
there's actually for those outside of the open source space, in particular for the transformer. I think one thing significant for GPT-Neo X was that it was one of the major models that had everything fully documented, and why they make this change in the architecture and so on and so forth. And that became like basically reference notes for all other subsequent open source models, because they were the early ones that were like doing a good transformer model.
Yeah.
And at least for the large language model.
So GPT-2 was actually open source. People didn't find that useful?
No, people do reference that as well, but it's like the code is there, and why did you do this?
Oh, I see. It's not documented. I see.
Yeah.
So in that sense, was OPT from Facebook useful? Because I've heard very good things about the logbook of OPT, where they had the daily logbook and they just published that.
Yeah, those were useful as well.
Yeah. Okay.
I think one thing that Neo X had going for it, especially the Illustrator community, is that it's not just logbook. It's just like you could just go to Discord. Hey, why do you do this?
Right. And the person who trained it will tell you.
Yep, someone there
hopefully. Hopefully.
One of them. So that's why we had the 0.1 and 0.4 models, because we were just in uncharted waters here. So like a lot of existing tokenizer took space as a major delimiter to detect and split. And the tokenizer we are using is actually a lot more simplified. So existing tokenizers, they scan all the text, they do a statistical model of like what pairs well with what, and so on and so forth, right? We did a similar approach, but instead of using like this token pairs well with this and should be paired with that, we just made it a trial list. So basically, we find the
data structure.
Yeah, correct. Okay. So we just find the longest matching string in that matching string that we have trained inside our token list, and then we just use it as a token. It's a drastically simplified tokenizer, and it doesn't use spaces as an assumption, which I know,
which is good.
Yeah, and that helps a lot of the Japanese, Chinese, and character models, because they don't have spaces. And I would even argue to fair say, like, if you look at like the really large models, like be it OpenAI or Claudia, right? Tokenizers are not really a thing. I mean, in the sense that the model can work even if you tell it character by character. It's maybe inefficient.
Did someone try it?
I mean, there was that jailbreak where, the system prompt, you put the character, then enter. You remember that jailbreak?
No, I didn't see that one.
Yeah, so you can literally, like, instead of like left to right, you can literally up to down.
Okay.
And you're just eating tokens for every character. No, actually you're eating 2, because there's also the new line. and the model understood it, because there's enough dumb data on the internet that it has learned how to deal with this kind of formatting.
Got it. Okay.
And if these models are already understanding things at the character level,
Okay.
everything else is just improved compute.
Okay.
Because we jump the multiple tokens.
Do you have any idea of your dictionary size when you use this tree data structure?
Yeah,
Because the typical tokenizer is like 80,000 tokens dictionary size. I presume yours will be bigger.
Yeah, it's around. I can't remember offhand. Our previous tokenizer is around 50,000. It's the new X tokenizer. Then subsequently, I believe this is around the same size.
It's not bad.
Yeah,
pretty good.
We didn't want to change too much on that size, but we just wanted to like just change the format.
Mm-hmm. Yeah, cool. All right. All right. What else should people know?
So world model is the
there's music.
No, you
sorry. Yeah.
You literally just landed into like here's the experiment zone.
Let's talk about it.
Yeah,
this is cool.
So RWKV fundamentally is still an input-output model, and you could do it for anything that you want. So there is actually another project internally on the Discord where it's doing vision modeling, and this is based on the is it mini GPT-4 paper, where you have an image model, put everything inside the latent space, and then you have the language model interact with that latent space, and then train both, and then you can do image stuff. Music was basically, let's just take the same model, same code. Yeah, you know how MIDI files work, right? So like the MIDI files, just input and output MIDI files.
Okay.
And yeah, and there's actually a lot of other experiments be it for vision. There's even an image generation experiment using RWKV. I'm not so sure whether it's in the list here.
This clip guided autoencoder, but I don't think that's
the
right one.
I wouldn't say it's a good image generator, admittedly, but it worked. So
the what I like about the transformers-driven image generators is that they can do text well, and they can do control very well. So like if you ask for, green, blue, red cars in arranged next to each other, they will actually know how to follow that. Whereas the diffusion models tend to treat it more as like a suggestion.
Yeah.
You know what I mean? Or they'll combine the green, blue, and red into like one car.
Whatever it felt like it, right?
Yeah, so okay, but just to get back on this, okay, what else? So again, I actually kind of want to establish the credentials of this thing. So, who is Blink? Is it rando on the internet, or like because again, never heard of this guy until he published.
Yeah. This is real name,
right? And you had I have this paper to work with, but it was only published in May.
Yeah.
You found this before the paper, and so I think it's very unusual for a researcher to effectively launch to the wider public without a paper and just get some kind of pretty decent community going, and then publish the paper.
Actually, it's the other way around. He got the basic community going before the paper.
That's what I'm saying.
Yeah.
This is unusual.
So the history behind it, right, and is that I think like a few years back once with GPT-2, transformers started to pick up steam, and I guess the whole world is starting to think, let's just abandon neural networks. So we haven't even gone into the code part, but so the main reason why neural networks were bad compared to transformer was that when you train let's say you just input a token and train a token for data sample, you have to wait for the compute to finish for that token, take the state, and then you train the next token. We'll get into how RWKV solves that. But basically the whole world at that point just concluded, neural networks, it cannot scale as well as transformer, let's just abandon it. and everyone just went in that direction. And Blink, or Bopeng, his actual name, decided, basically as an individual, literally at the Illutor AI forum, decided that, hey, I think we can modify recurrent neural networks based on the Apple paper, the light attention that I showed previously, to scale this up without, to make neural networks scalable and parallelizable in the same way transformers work. Because the reason why we branch away and focus on transformers is because neural networks were slow to train. It was never, it wasn't so much about whether was it good or bad. It was just, no one wants to wait 100 years for their billion tokens to train finish, even if they can throw a GPU farm at it. And that's where he started looking into it, like how to make the neural networks trainable in parallel.
And specifically RNNs.
Yes.
Okay.
And subsequently, with AI, and I believe there was also a few others, like because he was doing it very publicly there, came on board to sponsor the GPU computes required. Because even though I mentioned that on large context size, it is substantially cheaper. I think especially if you run an open source Discord forum for an AI model, it's like every day there'll be someone who thinks that they can train a 20B model on a single GPU coming in. The scale is still large, even though it's like 1/5 of 1/10 compared to Transformer, it still needs a lot of GPU. So that's why AI and the rest, Stability, I believe also is involved, stepped up and donated the A100s needed to train the basic models that RWKV had. So before those models were trained, right, we were like only having in theory like the toy models or the smaller models that this can match Transformer. We have no idea whether it can match Transformer at that
scale.
Yeah. And subsequently with the larger models, the 14B models and all that, and we can compare it directly with NeoX model, and that's where this paper came out. So that's the history behind it. It's like he wasn't really doing it in silence. He was doing it from Illuter. Then he branched out because this became a big project on its own, and that's where other people started coming in as well. So the part where we say that RWKV is a neural network that can be scaled up, can be rolled out as a transformer, right?
Yep.
The key thing that you will want to see, right, is this diagram here.
Yep.
This should be in the paper. No, sorry, the other one. Yeah. Accordingly, so what you get? So when you are running inference mode, ideally you should run it as a neural network. So this is a layer. So classic neural networks is that you have a state. The state could be start from blank. You process a token, you output a state, and then you rinse and repeat. And then as it keeps doing the output, it makes a prediction. In that one thing that so subsequently for RWKV, what happens here, right, is that we can roll out this neural network side by side, and then it runs similar to Transformer. But the key thing here is that the states are split across the layer. So this is what we call, in this diagram here specifically, this is what we call the time mix and channel mix. These are operations within the layer. Depending on how you want to view it, you could view this as individual layers, or as how we view it, we view like this collection of layers as one layer block. And each layer block pass the states to its sibling subsequently down the road as you process the next token.
Which is a similar RNN type feature.
However, the key thing is you do not need to wait for the upper layers to complete before you can go to the next token. So what happens in practice, and if I to jump to the diagram, like there's this graphic here. This is not 100% how it runs behind the scene.
I like it.
Yeah.
Okay. Whoever put time into this, kudos.
I made it.
Nice.
Yeah. So this is how you can visualize it. So the first layer is the layer norm. The layer norm this is standard layer normalization, that it doesn't need to, it just does it on token and doesn't need to wait for the other layers. But if you notice, right, subsequently to the right and to the top, these tokens, these blocks, right, need to wait for the blocks on the left. Sure. And this is like, once you go past the first few tokens, right, this cascades very rapidly. Especially, like this is only like 1, 2, 3, 4 layers. Most models have like 20, 40 plus layers, and the cascading patterns are happening. And in practice, once you start cascading there, you just saturate the GPU. And that's how it starts being parallelizable to train. You no longer need to train in slices like traditional RNNs.
Does big O notation help? Like, so we're talking about big O n squared for attention. Is this O of 1 or O of n?
I'm talking about like to go through the entire context. Yeah, this will be O1 per token.
O1 per token, On for whole sequence. Yeah. Okay. Cool.
Yeah. And
that's the core idea.
That was one of the key things.
What else is the key thing?
Other things is that so I think you are familiar with LSTM, right? This is how like traditional neural networks keeps things within memories. within here, within RWKV, we have two channels. So we call it the channel mix and the time mix respectively.
Is there a formal definition of channel mix and time mix?
Yeah, we can actually scroll, but with this will be like going more, going more into the code itself.
They're just weights.
Yeah, just weights. That applies according to the formula, but how in essence it works, right? More importantly, is you can see the data from the respective time mix and channel mix move to the next segment. How time mix is designed per se was that it's how it retains. So like how similar to LSTMs, right? Where it processes the state and the input, it may decide to discard certain states and keep new things in the state. Time mix does the same thing, but with a different formula. So it replaces the LSTM in that sense, and it can decide to keep things indefinitely. So this represents the long-term memories if you want to view it that way.
But classically, the problem with that is that it struggles with long distance.
Correct.
Does it have the same issue?
So that's subsequent. It struggles with long distance because it also needs to keep track of both near-term memory and long-term memory.
So you split it up.
Yeah, we effectively split up. So channel mix is subsequent.
Is this the perfect memory?
Yeah, this is the closer to the perfect memory. That is the short term. So time mix it has trainable weights on what it decides to keep and discard. Okay. Channel mix, it has a very strong bias in it towards like just the next token. So subsequently it will just like memories are stored in the lower layers, it just slowly shifts upwards through the channel mix. And this is the short-term memory, which at some point, as it just shifts all the way up, it will just disappear into the void. At that point, subsequently, then time mix should be retaining the longer-term memory.
Are you also sampling from a distribution? So are you also sampling from a distribution? So I noticed, for example, here that the illustrative demo is like, it says, my name is, and then it's predicting name is Bob.
Yeah, correct. That's a classic.
But is there some amount of temperature, it's the same concepts that we...
Same concept.
Okay.
So it's literally the same concept.
Log probability of distribution across your token space, and okay.
You could use Hugging Face sampler on top of it, literally. Okay. So yeah, the output is actually more like a set logic. Should we pause?
Pause for a bit. So we took a break for a bit, but now we're trying to cover what is the big aha moment for you? And you said it was something to do with cost.
Correct.
So we have this chart on screen. It's literally a chart of quadratic scaling versus linear scaling in terms of GPU time spent in text generation. And you said it was at training time and at inference time, just basically in everything that matters.
Correct. So look back to how RNN works from a high level. We do an O1 operation on a token, create a state, O1 operation, create a state. So this just scales linearly. You want to throw 1,000 tokens at it, on inference, it just scales linearly. Subsequently, for transformers, you take in a token, you process your first token. It may be O1 here. Subsequently, when you generate your third token, you need to compute your second and first, and then vice versa. So you do your 1,000 token, you need to compute back your 999 previous tokens. And as this keeps growing, this is your quadratic scaling, and this is why we had this graph of the amount of cumulative GPU time that you need to spend to generate all these tokens respectively. And this is fundamentally just transformer versus neural networks. On inference. The reason why, and subsequently, neural networks did have the disadvantage of, let's say, not being able to parallelize well in training. But as I covered, RWKV kind of solved that by effectively splitting the layers, allowing you to train different parts in parallel. And some people will go into the academic debate of technically the second and third token is not parallelizable until the first is done. But once you get into I can saturate a GPU LAN, it's
way better.
It's just academic debate. We are done. And so training, in essence, has always, this is be it for transformer or neural network, is I need to do an inference pass. I look at the logits. Then I backprop to see what went wrong, and I update the weights. Yeah. So the inference is the forward pass. You still need to. It's part of the training course. As you backprop as well, like needing to only look at the current set of tokens and the state instead of like everything, also reduce the amount of things that you need to backprop. So it's just that it's like there's so many factors involved in just reducing the overall inference and training time. And that was something that appealed to me because in the long run, I mean, all of us want our model to just run blazingly fast, right?
Yeah. And also on minimal hardware.
Oh yes, that.
Which, as far as I understand, you still have 14 billion parameters. That's not going away. You still need the RAM to store 14 billion parameters worth of stuff. That's not going away.
Yep.
Okay. So RAM is unchanged.
Yeah, on the RAM side, but the working memory is reduced. So typically you need more than 14 for transformer. I mean, let's not touch quantization. But in this case, we don't need to keep. Like if you really want to like save RAM, it is possible for you to do token by token inference so that you don't need to keep your states in history. You only need to keep your current token state and your next.
Yeah. Okay.
And yeah, and that's actually like one segment of our community just purely porting RWKV to C++ based model.
RNNs.
Yeah, and running it on Pis and stuff.
Raspberry Pis.
Yeah, it's interesting to watch those.
Is JAX interesting to people? TPUs?
There is some interest, but
people don't have access.
No, I would say frankly, the people with the most interest also happen to be the people who have free TPUs.
Yeah.
So I don't know.
My understanding was Eleuther was also given a whole bunch of TPU hours. Therefore, they wrote all their stuff in JAX.
Yeah, and if you can train it and then you got the weights, you can always just run in something else. It doesn't matter, right?
Yeah. Okay, cool. All right, and then there's a chart about performance, and it shows that RWKV is competitive, or actually better in some of the reasoning challenges, which that's something I definitely would look for, right? Like, and it's fine if like your speed is faster and all that, but if the reasoning quality sucks, then it's not a very useful language model.
Exactly.
So
this is like literally us saying there's
no trade-offs.
Yeah, you don't lose out in that process.
Okay. Big question then. Why isn't RWKV a bigger deal right now?
So one, we are not a commercial organization.
Okay.
This is literally the pure open source play.
But you could have done the Stable Diffusion thing, which, Stable Diffusion launched. It was by a bunch of nobodies before that. It's from literally split out from Eleuther, but they definitely had some hype. They definitely I interviewed Shamim who got in, and this is something the reason I ask you so many things about how did you find out RWKV, because I think the generalizable skill is how to be early in AI. Because being early in AI is very valuable, because then you were there to see the how things developed instead of like picking it up later like me. Anyway, so yeah, why is it not a big deal?
You want me to be frank?
Yeah.
We just suck at marketing.
Okay. That's fair.
I mean,
this is part of it.
Yeah, this is part of it. Yeah. So maybe.
But again, I don't think that is entirely the cause.
Yeah, I'm sure definitely. I think the other major segment right now as well is that we were really late on the paper.
Okay.
Like, one of the weirdest thing right now is weirdest thing right now I feel that is that RWKV is starting to have its moment right now.
Okay.
Is that ever since that initial paper came out, there was ResNet. There's I think there's two more. There's a few more additional papers coming out. One from Microsoft, one from other organizations that are literally exploring the whole idea once again of scalable neural networks.
Okay.
And they are citing RWKV as part of it as well.
Okay.
And I think for most I think it's existingly, why switch to this model when, even though we have proven that yes, it's scalable to 7 and 14 and that it can match transformers at similar param and training size, but all this is very academic because the community, right, the community at large, especially for the English speaking community, right? They don't really care about this. They care about what's the best model that I can run on my computer, at least within the open source space. And by that, and even though we match in performance for things in the same data set, the keyword is same data set. Like this benchmark is not even red pajamas yet. It's the power.
Mm-hmm.
And when you have models that are like, be it like Falcon being trained on much larger data set, especially for an English use case, it makes more sense to use that.
I see. So there will be another paper coming that is RWKV trained on red pajama.
And
that will presumably
larger
do a lot
data
better.
set, and so on and so forth. So I think we are still in the stages of reaching that point where we train on the larger data set.
Yeah.
The only reason why we have a bigger outsized impact compared to like the other models is frankly because half of our Discord came in not for English, it's for other languages.
Yeah, that's great. And there is a definite very US and English centric bias towards these models, and it's to me kind of poetic. Like there's nothing in the architecture of RWKV that particularly bias it to be really good at other languages.
No.
It's just that as a community you decided to prioritize it in your tokenization in your data sets. That's it.
Yeah, that's it. I would even argue that I'm more surprised that, especially on the European side of things, that we don't have more models that actually focus on even the European languages, because that is like a softer jump to character, Japanese and Chinese characters.
Because they're all romantic. I would say, well, one, Europeans are very hostile to tech advancement. You know, the first thing, they have never met a technology they cannot regulate, right? Everything just ban, regulate, ban. Whereas you know, and then on our side, and the Asians like to have waifus, and so that would be my guess.
But I think back to the benchmark, what excites me most still about this is that it just means that we just need to scale. We just need to scale this model and with the right data.
To like 40B?
40B, 60B.
Yeah.
I mean, params is one thing, it's data sets.
Okay.
And GPU time.
Yeah. So you and I talk offline about ideas for getting data, getting compute, and all this. Okay. So this is like a project that's ongoing. Okay. Anything else for the future of RWKV?
The biggest one would be So this is back to how, remember I said evals doesn't doesn't highlight everything. Like this is nice and all, the evals, but let's being realistic on another weakness on RWKV side is that now with the rise of like, let's say 100K or 32K context size windows, transformer model, RWKV currently is trained to handle, let's say 8, or even some people have already trained it to 16K sizes. It has, and well, it will, as a neural network, it will happily keep going on for infinite context length. It will just keep generating. Does it do well? That's the answer is no, because if you didn't train it to handle that situation, and there's actually a chart. So, for example, if like the prediction, the power test loss, right, it does improve over time. Let's say if we go down the context length, but this is if we train it. And what is not seen here is that if we were to do let's say run it further, it'll just go back up because it was not trained to handle that. Well, it technically can run. It suffers from the longer context length, and that's the part where RWKV, especially in like Q&A tasks, in huge documents, like you get Claudia to summarize giant documents. That's where it starts to
look like
fall.
None of this is fundamental. It's just you need more money.
Yeah,
that's it.
And no, there is actually a fundamental part. So one of the things that I was doing and am actively helping within the committee right now is that we found that the existing way to scale the memory was not that efficient, and we were just being realistic ourselves. If we want to hit 100K, we need to change this. So one thing that I'm actually looking forward to right now is actually those experiments. We have already started scaling things to be able to handle things at transformer scale, be it the 4K, 8K, in terms of like how it handles memory really well. And we want to like extend it to be like 16, 32, and 64. And we that is within our roadmap. And that's the exciting thing, because once we have that, like it able to handle long-term memory within those sizes, it removed what many people in the community felt, right, was the last architectural limit. Because once it's able to handle memories like context length with the same as transformer, we no longer need to do all those, like, you know how existingly like people do like long conversation in transformer, they just discard the rest and the sliding window. This is like the better version of sliding window. You have the model can handle the sliding window perfectly. It can keep remnants behind it.
Sure.
And that's something that I'm really excited and invested towards, because this is back to the full circle of how I came into RWKV. I want my model to handle 100K tokens, 4 megabytes of HTML, whatever I throw at it, and be able to process it.
But it'll be lossy.
The later half will be lossy, but the key thing is extending the non-lossy part, and we are aiming to extend the non-lossy part.
Okay, interesting. Great, that was really good. Oh, one thing I wanted to cover before we leave the topic of RWKV altogether. There's a couple things. But first of all, what is it like working? Basically, it's a all volunteer Discord anonymous community. You've never met any of these other people, which is like, it's only been done one other time successfully, which is Eleuther, right?
Correct.
In a way, RWKV is kind of new Eleuther. Obviously, Eleuther is still going, but in as far as active research in like something that's completely untested by like complete nobodies, it's you guys. What is it like to organize a group like this? I've never been involved in something like this before. It's so weird.
When we use the word organize, it makes it sound like there's more organization than it actually has.
I would like, yeah. If I think about how I've typically done projects, I would like try to assign roles or try to have regular meetings. Or like try to have some. Everyone is volunteers, and nobody has any like means to order people around or anything like that. But like, how do you collaborate if you don't know what each other are doing, and don't have people that like are not committing to deadlines, or like, do you have a Jira board? Do you have? Okay. So bringing back to the Discord. So Blink is a busy person. You are definitely very involved in the Discord community organizing. How do you get stuff done?
So I think Blink is also the one who has access to the main Eleuther AI and stability's GPU donations. Okay. So he's the one that is very focused on training the big foundation models, and that's what he do. So right now in our current pipeline, he is focusing on the world model and subsequently some experimental models for RWKV5, which is the next generation. And the world model is our next major foundation model. When it's fully trained, it will cover all the other languages. And from there onwards, he just generally continuously keep the Discord updated on the progress of it, be it like how's it going, where is it going. He constantly highlights the projects that are being submitted, and the internet is just now.
Oh yeah, I've been tethering the whole time.
Hope
that's okay.
It's okay. And then subsequently he updates with his ideas and his plans and so on. Like there's even ideas, as you can see.
It's pretty cool. Yeah,
for RWKV6, yeah. It's like long-term, but these are like big ideas, and sometimes, in a lot of times, right, he's very focused on the text models, and also some of these ideas need to be tested and validated. So that's where things starts branching off per se. So for example, one area that I started being active in was that when I came in, I was being more active in, let's say, the packaging the inference code to make it more accessible. So I think one of the things that I showed was the RWKV Node.js module.
I can see it.
Yeah, fair enough. The Node.js package where basically you can run RWKV in Node just to make it more accessible. And then subsequently I was supporting that. As more people came on board, like trying to run it in their respective languages, it's okay. I'm just going to keep going. Yeah. I subsequently moved on to focusing more towards datasets and RWKV5. But this is the area that I'm focusing on and most active. And this is how we start organizing as well. Like individuals generally have their own area of focus of what they want. And it's very focus driven on, in a lot of cases, aligned to them. So for example, like the people who are working on inference, the CPP model, the Onyx model, the CPP versions, right, where it takes the existing model and converts it accordingly. They are highly motivated to do this because they want to do the inference in their use cases, in their Raspberry Pis, etc. People like me who's in RWKV5, we are actually more like, we know there are some weaknesses in the model and we are trying to make those changes to improve. So we are like actively changing the foundation code. Then from there onwards, there are like channels. So these are RWKV5 channels. I mentioned the inference channels, the CPP channels. And then from subsequently, there is also the multi-model channel. So, and this is an area where I am not fully active in, but there are individuals who are very interested in like getting visual recognition, mini GPT-4, audio. Apparently the music thing is catching up within the community right now. People are getting excited about it, but this is where various other individuals come in to just contribute to that side. And this is still within the sphere of like code and engineering. And like if I go subsequently back down another step, there's also the multi-language channel and the dataset channel. And this is where you find individuals who are just, I would say they are like playing the role of librarians, who's just trying to like find the right data sets, label it, collate it, clean it up, and then put it in part of the training. And their typical focus is that they want to support their language better, or they have their, I guess like you alluded, their Waifu use case, they want to make it do better. And that's how the community-driven effort is done, because everyone actually has a certain incentive and alignment, and they just double down on it effectively, and they start to take a heavy active role in the channel. So like, frankly, I'm not going to say that I'm active in multimodal because that's an area where I'm not really active in. Yeah. And so on. And that's how we try to like self-organize, and we share our notes accordingly. We sometimes just casually just hang out on the Discord voice chat or whatever, and then we just talk to each other. But that's more of like the more casual stuff of it. But how things get done, it's down to the individual groups.
Has Bo stated his ultimate end goal? Apart from this is cool.
I think we had I had several Discord conversations with him. I believe that because I did ask him frankly, like, is he planning to make a commercial entity of it? Actually, tons of people have asked this because that seems to be the pattern. And he seems to be heavily inspired and wants to go towards the direction of creating the equivalent of a Linux foundation, but for AI models. So he really wants this to be open source. And that's actually part of what motivates me to just continue on in this Discord as well.
Yeah. Do you think that is that a serious effort? Because I might be also looking to explore. I know some friends who are also working on like an agent protocol that could benefit from a neutral non-profit foundation type thing. So we might want to work together to set it up.
Yeah, sure. Because I did post to him a few times like we should at some point organize and set up the actual foundation rather than the informal.
I think I know the people who would be able to help.
Yeah, that would be great because I mean, like, I think for us setting up the foundation will probably be one big major step, because then it will also simplify the process in terms of like being able to handle GPU donations and stuff like that.
Yes. Oh, that's a good point.
Because right now, a lot of the donations.
Well, so I saw that there is an RWKV Foundation.
Oh no, it doesn't fully exist yet.
Oh, okay. Because he listed himself in the paper as.
This is back to like the paper. The paper requires you to list an organization that you belong to, and if you don't have an organization, what do you put?
Okay, interesting.
So it's like, okay, at some point we will need to set that up, so he just went ahead and filled it up.
Yeah. Cool. I think that's the RWKV portion, unless there's any other parting notes.
Yeah. The Discord is filled with people always trying to do many things. Yeah. If anyone has any interest in a really specific task, go ahead, join in. If you are from a foreign country that it seems like no model seems to care about your language, please do join in, because we want these people. We want to support your language, and we want to know how good or how bad our model is in that language.
So what I would do here as a product manager is like put up a public repo somewhere of like, here's all the language we want to target. Here's our completion ratio. Like, check, blank, blank.
We need someone to do that.
Exactly. This would be a classic PM type of thing. But anyway, so anyone listening, if you are interested, Eugene is Pico creator.
Yep.
You seem to be all over the Discord, so it should be pretty easy to find you.
Yeah.
Okay, and so that's basically the RWKV portion. You had one more comment about alternative models, and you mentioned that you actually, apart from RWKV, which is one thing, it's not like your whole identity.
Yeah.
You're very involved right now. You said that there's also potentials for diffusion models in text.
Oh yeah. So I think for me the key principle is that we want to make sure we avoid the trap into landing on that one model to rule them all, because all models will at some point, from an architecture point of view, may do some trade-off. And if, let's say, we go back to the point where maybe all we need is a scalable model and a good data set, it's in the community best interest, or more like the whole world's best interest, because we are burning a lot of GPU energy and time to find an efficient model for all the respective use case.
Okay.
And all these are all trade-offs. So even if, let's say, like fast forward, maybe RWKV became the prominent model, I would still say that we need to explore alternative models, because all models will have its weaknesses. So one of RWKV's and Transformers models' weakness is that, and I think there was a paper that covered, is the multi-epoch, and how it can only how training, you should ideally train for 1 to 2 epoch.
And that's Aaron Kotsumaki or whatever his name is.
Yeah, I can't remember off my head, sorry. Yeah.
So his paper is literally titled one epoch is all you need.
Correct.
I actually have observed that this is strange to me, that you only train on 1 epoch for a whole data set.
Yeah, and anything beyond that, and we can confirm, even for our model, ours is more like closer to 2, but the idea is still there, that it starts to overfit, and it starts to degrade in a lot of things. And I think this is a serious enough problem that within the Transformer community that we sometimes joke about the token crisis.
Yes.
That eventually you run out of tokens.
Do you think there's a token crisis?
I would say if we are aiming for AGI, there is a token crisis. But if we are aiming for useful small models, I don't think there is a token crisis.
Right.
Because
let's talk about AGI, because the small model stuff is I think a given at this point. But right now, let's say Llama 2 was trained on 2 trillion tokens. Can we go to 20 trillion? Can we go to 200 trillion? Is there orders of magnitude left, or are we like basically almost done?
I think that one thing amazing about the Llama paper is that it showed that even at 2 trillion,
not leveling off.
It's not leveling.
The loss is still going. Yeah.
So you could potentially train it for 16 or whatever it is. We don't know what's the name. But the problem here is, where are we going to get the tokens? Because we already established that it's equally important that you have good data.
Quality tokens.
Yeah, that goes in rather than junk data, and that's the crisis, for lack of a better word. And I feel that it might actually get worse, mostly because, we can keep crawling the internet, but now with AI models dumping content to the internet, you actually need to figure out what is quality content, and you need to start filtering. So this is literally like a librarian's job. Plus, like we literally have, one of the things that we explored within our community is like starting to classify our models. Our data sets. Literally taking the library classification in
the Dewey Decimal System.
And then using that accordingly, because there's just so much things, and as long as we currently, one of the biggest gap that we notice is that while there are a lot of books, a lot of them are stored digitally as images. So in terms of text, there is actually a shortage.
Okay, run an OCR step. I don't know.
Easier said than
done.
And that's where the token crisis is. But I mean, this is back to why I'm interested in alternatives, because the reason why I pointed out the diffusion model is that Transformer and large language models right now having that 1-2 epoch limitation, and you go talk to people in the image space, And they're like, what?
50 epochs. Okay.
50 epoch is low. We do 200, 250.
Yeah.
And there's various reasons for it. I mean, this is pure speculative. My speculative reason for it is that diffusion models work so well with multiple epoch because each training epoch, right, it is randomized with noise. And effectively, each training run, even if it's the same data sample, it is different due to the noise introduced or whatever is truncated and removed. And that's why it held up well. I mean, and if that is the case, shouldn't we be exploring more as well into diffusion models, even for text, into emulating parts of this behavior, or exploring, as I said, like one of the reasons why diffusion models are not being used for text is because it's slow. Shouldn't we, alternatively, could we be exploring how to make it faster? And this is why I feel like even we talk about RWKV having the trade-off, yes, it's faster, it's scalable, and whatsoever, there is other trade-offs that is still limited. It still suffers from the multi-epoch problem, and diffusion models may actually represent a potential for us to escape this token crisis and maybe train on our data set 200, 500 times.
That's interesting. I don't know how to respond to that apart from, like, I think it's a new perspective I haven't heard.
Yeah, but to be clear, this is all
Speculative.
theory, and I could be completely wrong.
Well, okay, so to me, the speed thing really does matter, and being able to stream token by token actually is known to be good UX.
Yeah.
Right, and I'm not going to wait for my essay to like slowly materialize from the diffusion
Yes,
process,
definitely.
right? Maybe you find some use cases that.
Or maybe we can
be.
just extract the part
Right.
where it's trained with noise and somehow survive multi-epoch.
Right. And then the other criticism off the top of my head of what you're saying is that, like, even RWKV and typical transformer models would have random initializations. So why can't we? If your thesis is that starting from random initializations gives you the ability to do multi-epoch, like
It's not so much, diffusion is not just random initialization. There is randomness in the data that they intentionally put in, and as they remove in training. So it's not just at the
I see. As part of the training process, they
in the
actually
middle
I see,
of the image.
Right, that makes sense.
Yeah.
Okay, got it.
How we translate that into a transformer prediction training, I have no idea.
Yeah. I mean, so my analogy would be to just make a Frankenstein RWKVD that just has some weird thing diffusion kind of slapped onto it, and then you're fine, So.
And then maybe it proves that it's yes, or maybe it just goes wrong. And I'm all for it. Like, someone needs to try.
Yeah, someone needs to try it. Okay, cool. So we're going to wrap up with just your you have displayed today an impressive amount of knowledge just across the all this stuff, and you don't have like a research background. Your advice to AI engineers getting as deep as you, who want to get as deep as you. Well, any thoughts?
So I think your article articulated very well that there's going to be divisions within how we approach this. So AI engineers, sorry if I don't quote it correctly. Yes. AI engineers, then in my head, the next level.
The beauty of it is that I define the two words, and then everyone has their own definition, but they all roughly project onto the same embedding space.
Okay.
It's beautiful.
Yeah.
Yeah.
So AI engineers, model trainers, and dataset curators, and ML scientists. So I'll loosely define as a tree. I ignore the full stack because every company needs it. So within this tree space, there is actually a lot of ways anyone can come in without knowing anything. So let's just start with AI engineers. Don't be like, even though this whole topic, we even dived into how the layers work. We also showed how the math works. Frankly, for an AI engineer,
not required.
You don't need it. Your main thing that you needed to do was to, frankly, just play around with ChatGPT or all the alternatives. Be aware of the alternatives. Just be very mercenary. Swap out to Claudia if it's better for you, or swap out to an open source if it's better for you, and just play around the prompts. Learn prompting techniques like one shot, two shot, few shots, and then from there on, you can start building your agents, stacking stacking your prompts and in sequences and stuff like that, and you are able to build applications that do anything in terms of the AI space, and all this without knowing all this nerdy stuff or the hard engineering, because that's all you really need to actually build a product for the user. Remember, you are supposed to focus on making it for the user. They don't care if it's RWKV or transformer underneath the hood. They just care that it helps them. And I would say like Notion probably is like probably one good example of how they use it, because we know underneath the hood is OpenAI, but it's really useful for them. Yeah.
No, but so I obviously agree with all that. Let's just say that people are there already and they're just curious. They want to do what you did.
So that's where you start going down the layers.
Yes.
So the next layer you go down in is subsequently training the model, from scratch, fine tuning and encrypting the data set. And this is where you still do not need to know the math, but you need to know, like, you need to have a rough sensing on how the model works and how the certain models, and in this even within the open source transformer space, certain models are better trained in certain sequences with certain learning rates, and you just need to get a feel of it. So this is just like collect the data set, try it, see the loss.
You literally did this.
Yeah, at least for RWKV and the
That's a lot of work.
code gen models. Yeah, it's not a cheap work too, because you need GPUs.
Okay, and that took you how long?
I think I code gen alone was like 6 months, and then this RWKV I've been doing this for like another 6 months, and that is it's just pure experimentation. Like there's no right or wrong, because like especially if it's in a different domain, like recently I was like helping someone on the RWKV Discord regarding the music generation domain, and my assumptions for learning rate and all the patterns, right, were just completely thrown out the window, because the music model just fundamentally is different in those sense. So that is the exciting thing is, because it doesn't really have any specific rules and guidelines until you trial and error to a certain space. It also means that you coming in is as fresh as anyone else coming in last year. It's really that kind of uncharted space for everyone, and especially as you start exploring to new domains, your existing knowledge may actually matter, because sometimes, like, I think a few papers already covered this, that's like how you train your model in certain sequences also matter. Like you want to train a certain set of knowledge, and then you extend that knowledge subsequently. But if you're talking about material science or genetics, how am I supposed to know what is foundational knowledge and what is extended knowledge? I have no idea. Maybe you do. I'm just picking an example of, yeah. So, and the same thing for music and so on. So those are things where even though you're outside the space, is where you can come in just at the data set level. Now you want to peel off to the next layer. Let's just say you want to look into modifying the model, the foundations of it. I think one of the beauties about this current boom is that even though I did my toes early, like before the transformer wave and in the early neural network phase, frankly, almost everything that matters was basically in the past 4 years. Like there were a lot of things that, be it in academics, that were before that, and they were mostly dealing with models that were under 1 billion parameters. They pretty much no longer matter. And
can you be more specific? Are you talking about like concepts like dropout?
Dropout surprisingly is coming back, but like things like, for example, like, okay, I know I'm shooting myself in the foot because RWKV is a neural network, but if you're just trying to get transformers to work, you don't need to know LSTM.
Yes.
Yeah. You don't need, there's a lot of like pre-knowledge in neural networks that is irrelevant in the transformer era. And maybe some of it will have a resurgence, but to get up and running is not a requirement. And I think this is where you could either go the very academic way of reading papers and stuff, but frankly, what I found was way more useful was, I can't pronounce the name again,
Karpathy.
Yeah, Karpathy, yeah. His series of videos.
There's a hero.
Yeah, that is really, really good. I think even though I read some of the read some of the papers and guides before that, it really helps that it starts from zero, because you can see how it happens part by part. And even though we will not use how the exact same code that he used, because like he re-implemented the backprop and all that, and we are just going to use Torch for that. Yeah, PyTorch for that. That's where you get the aha moments on how these building blocks work and how it fall into place. And like I had fundamental misunderstanding of how backprop worked until I actually watched this video.
Oh, really?
Yeah, and I think that's the scariest and craziest thing about AI models sometimes, is that you can actually have fundamental misunderstandings, but as long as you make the building blocks and it connect, and okay, loss is great, it works.
Yeah. Well, so even the gods of the industry, I don't know if you read the Swiglulu paper. So there's these alternative activation functions, like there's ReLU, and then people are always looking for different slopes, and very famously, the Swiglulu paper had this line in there that was like, "Yeah, we don't know why this works, but it works." Can't explain it.
Yeah, it literally happens here and there on Discord too. One of the funny things that I'm doing right now in RWKV 5 experiments is that, okay, we are going to do this change, where we're going to run this train, make your prediction. Will this model beat this model in this loss curve?
As a game, as a betting.
It's a very informal.
Yeah.
It's literally a buddy kind of like
right.
of bet, but the fact that we can do this kind of bets even though we like understand the code, it's like just goes to show like how often like, oh wait, this didn't go what we predicted.
Yeah.
No one, and that's why even if let's say you don't have a PhD or so on and so forth, right? Heck, even if math is not your specialization, you're coming in as a developer. I'm going to say frankly, like I didn't come from the research right now. The extremely math heavy stuff is what I struggle with. What I do sometimes is I copy and paste the math into GPT-4 and ask it to explain to me,
which is good
in plainer language.
It's very good at that. So
yeah,
that's fine.
Yeah, and so, but the thing is, there is lots of value add beyond that. One thing that I realized, and this is not specific to RWKV, this also happens across a lot of open source models, is that a lot of ML scientists, when they really built this stuff, the focus was more of like always get it to work. It was never about getting it to work efficiently or getting the code documented or organized. And Stable Diffusion literally went through this whole journey. They had the code and the model that worked, and the community just started, and engineers that came in with zero machine learning background started picking it apart. It's like, no, this you could replace this with this that does the exact same thing, but it's more efficient. Like one of the major breakthroughs, for example, for GGML, and this happened some time back for a bit, Llama models and all that, was that someone external from the AI community went in and implemented memory mapping.
Yes, I saw that. Yeah, I forget her name, but yeah, Justine.law is her URL.
Yeah, and she didn't come in as an AI expert. She came in as a software engineer.
Yeah,
and
these are all just very, very straightforward. In her world, this is normal. Whereas for the researchers, they will be like, yeah, I don't want to.
Wait, what is memory map?
Yeah, exactly.
Yeah, and there are a lot of things like one of the jokes that I have right now is that every month there is a research ML scientist that is rediscovering the number 32.
Why?
Because be it like or someone in the community writing the inference code, because GPUs, especially CUDA NVIDIA GPUs, tends to work really well when they align to the batch size of multiples of 32.
Oh.
And if you've been in the gaming industry, especially when you write shader code, right, this is like well known, like just given knowledge, and people are just constantly rediscovering. Oh, maybe if I just adjust my data set or my data size to fit this batch size, suddenly I get 10% improvement, and yeah, and then it's like these are things that, once again, because they were so focused on just making it work, that they won't know outside space. And that's why I would say, right, if anything, right, now is the best time if that you don't know AI to have people from different background coming in, because your contribution could be from data set level, how to train the knowledge, to shader code, to heck, how to memory map, how to cache data. There's so many gaps.
Building the UI, I saw that you guys have a UI as well. Or maybe it's not maintained. I don't know.
No, yeah, there's someone in the community. Yeah.
Yeah. Cool. I think that's
layers.
that's very encouraging and good to know. And then I think the last thing, I left this to the end because it's kind of uncomfortable, but also just fun bonus, which is I'm really trying to do an AI waifu episode. I think that at least in the open source model space, the most motivated and surprisingly competent people are the people trying to build AI girlfriend. And you are one of the few people I've actually met who, like, you interact with these people, right? Like that, then they are like, just what are you seeing? What's interesting? Like, and there's, apart from RWKV, there's also other communities, right?
Right.
The uncensored models. I think Wizard LM is part of that.
Correct.
Just like, can you sketch out like what is happening in that world?
So, I mean, credit where credit is due, right? Like, we shouldn't be king shaming or anything on that. And these are some of the most motivated and sometimes even the most technical competent people that literally move mountains in the code base. And I don't mean that lightly. I think those active in the RWKV Discord will know a few members that literally just came in out of nowhere, and it's like, okay, let's just rewrite the whole how CPP and GGML code does work, and great, it's way faster, and there's a lot of them. Their motivations is still very inherently is that they are very, I guess it's the fastest feedback loop from code.
They are the users.
To the user, yes, exactly. And they want the model to align better. So and the thing is, getting an AI waifu actually spreads the whole freaking domain.
Why?
Because from the very top, from the very bottom, right, will be like, let's say the model architecture. So let's say if the model architecture has issues paying attention to historical conversations, for example, you can have long conversations and then the model will just forget stuff.
Yes.
Not ideal per se. All the way to the very top would be like you want your model to stay in character. Your system prompts. This is literally alignment problems, but the alignment is not to an ethical standard. The alignment is to stay in character. And that includes doing things that makes no sense. Like let's just say you take one of your favorite what's the character trope for this? The silly scientist or silly airhead girl. I think the American equivalent would be dumb blonde.
Yeah, bimbos.
Yeah, I'm sorry if I offended. But then, and the idea there is that the characters may make, as in character, will make some very silly mistakes. Yeah. And you want to align your model that way. So that's alignment.
So, okay, what are people doing to solve that? Just in case you've seen anything interesting.
So,
like, for example, the Dan prompt to me was very interesting.
Yeah.
Like give people points and then deduct points, and like it's trained to be very scared of losing points.
Correct. So from there on, it's really more of like prompt chaining methods. They are embedding.
Which makes it slower.
And then so it keeps going back and forth the chain. So you see, they adjust the prompt, then it's too slow. Then they want to optimize it. Then they look into how to train it better data sets, and including their favorite character stories from whatever sources they can get. Because one of the existing problems for AI models, even from the foundation model, right, is that even though it can partially impersonate a character, if you ask a real fan, in a lot of cases, it falls flat, because what's happening is reading summaries and quotes and memes and impersonating at a very high level. Yeah. But it's not impersonating on a very deep level. Yeah. And that's where people start exploring the data set. And because these members are also the same members that do not have a giant GPU farm, they are very interested in optimizing it, be it through LoRa or fine-tuning. It's like, what's the best learning rate? What's the best way to fine-tune this limited GPU resource for the benefit of all people?
The LoRa techniques and whatever else, are they applicable to RWKV?
Yeah, RWKV does have a LoRa trainer as well.
Okay.
And
that's relatively commonplace now. Everyone has it.
Yeah, I think pretty much every open source model has a LoRa trainer.
I will say I've actually struggled to find, like, LoRa seems to be very common in the Stable Diffusion community, but in text models, I haven't really seen that much adoption in my circles, but I think maybe you've seen it.
I guess the problem is that LoRa has, okay, so like, I think in Stable Diffusion, LoRa is a lot more powerful, as in, I find it hard to come up with a use case that LoRa cannot support. But for example, right, in the language models case, right, LoRa cannot teach new language. It cannot. It sometimes may struggle to teach new techniques or new concepts. It does well into adding and refining existing knowledge, and this is the part where how do we know whether it works or doesn't? We don't really know because the line is very gray, and I think that frustrates a lot of people when they're using LoRa for professional use, because you can end up doing LoRa and for it to fall flat completely. But this is where back to the character AI community, it's actually very suited for that use case, because if your character is popular enough, there is some base data in there, and you're just effectively fine-tuning the speech patterns and the data from there.
Yeah. So I'll call out, so I think you say character AI, but you don't actually mean the company character AI, right?
Yeah, sorry about that.
It's the companies that are like them, but sex positive, let's just say.
Okay, yeah.
Whatever. So there's character AI, there's Replica. These are the two, like, trad. I would consider them like trad in terms of, like, they are in the common consciousness at least in traditional AI circles.
Yeah.
And then, for example, I recently came across Venus.chub, which, yes, it's one of those. But like 2 million users in 1 week. That's the number that I got. Crazy, like just huge.
Yeah, then I think there's also a lot of it, especially when it comes to like specific domains.
Yeah.
Like be it anime, be
furries.
These
are all like, look, like, I mean, this is all the full range. You want to simulate humanity? Yeah, there you go.
I know.
a lot of times it's about sex.
Yeah.
Okay. So I don't know if you have anything else. I'll mention like one other piece why I'm interested in this is because if these people could be actually, honestly, they're the pioneers in terms of modeling what a human is, and we actually end up figuring out how to like encode a human personality and identity, and we might actually end up like this weird path that we're taking might actually end up in like mind uploading, which is what I'm thinking about.
I think that makes sense in many ways because they are also the most nitpicky about it.
Yes.
It's like they can tell when the character is out of character.
Yeah, so you know, and they're doing it without access to the full information, but like I do think that like this is a real path towards like immortality in some form, and I think there will be people interested in mind upload, and it will come from this community because no one else is working as hard on essentially serialization of a person. I
think there are two variants for it. Like I think one is the one that Facebook is attempting, which is I have all the data on you.
Yeah.
And same thing, I have all data on this character.
Yeah.
And now you have a virtual half per se, and your when you decease, whoever's left can interact with that. I think that's slightly different from mind upload. But then subsequently, I think then the next jump would be, but that could be like the building block to the next major jump, which is like really scanning your brain and then figuring out how all this connects. And
sequence your DNA, like do whatever, right?
Just like this is like a completely wild tangent, right? I sometimes think that we overestimate how far we are, because in my opinion, right, like, and this is for me in particular with the Stable Diffusion model, is that
if I can get the world image model effectively stable diffusion was in under 100 gigabytes, and now I have all the world knowledge literally in a transformer that's less than 100 gigabytes. No offense to myself, I don't think my personality and my memories is more than this.
Yeah.
We could, even if I 10x it, I could store this in 2 SSDs, 2 hard drives, and if we really break it down how to serialize it and handle it right, perhaps we are actually not as big as we think we are.
Yeah.
Because our brains are actually handling a crap ton of other functions, and this is like a tangent to the biological side. Your whole body,
you're breathing, you're pumping blood,
your movement, that actually takes up a lot.
Yeah.
And if you really want to strip it down to like just pure text and vision, because since now if you upload your mind, you no longer need the rest of that.
Yeah.
Perhaps we may find out that it's actually a lot less than we think.
Yeah, so George Hartz was on our podcast, and he said 2 gigs.
2 gigs.
He wants to quantize himself, which I'm like, I think you'll lose something if you quantize yourself. But
I won't push so far to 2 gigs. I'm still within the terabyte range because, frankly, that's all we need.
That's all we need. That's all we need. Yeah. Cool. Great. So yeah, thanks so much for being very willing to get on and talk with no prep. We did some prep, but it's a very unusual podcast episode. But I really enjoyed it.
We literally just met yesterday in Singapore.
Well, but I know you've been on the Discord for a while, and I could tell you like you're very serious about all this. I think it's very unusual for someone like you have a job, but this is like a second job essentially.
Yes.
But you are really enthusiastic and passionate about it, and I think that's very rare. And I do want to encourage more people to do it. And so thanks for sharing.
Yeah. I'm glad for having me here on a very last minute basis. Like, we did not book this room.
There's no room.
We are literally guerrilla podcasting in some corner. If you see random intermissions and cut, right, that was because a crowd just went by and there was noise and we needed
aunties had to go for lunch. But no, I think it's actually a bit charming. I think some podcasts can be too polished, and sometimes it's just nice to see like, hey, it's just 2 guys talking. Yeah, that's all it is. Cool, thanks.
Hi, thanks for having me here.
All right.
Oh, is